This meeting is being recorded.
In this video from chapter 17, we're going to look at some factors that can affect solubility. So when we have these slightly soluble salts, things like having a common ion present, and later we'll look at pH can also affect the solubility of these types of compounds. So if in this scenario here, we'll look at the common ion effect, and if one of the ions in the solution, the equilibrium equation, is already dissolved in solution, the equilibrium will shift to the left and our solubility of our salt will decrease. So let's take a look. Say we have our barium sulfate here. KSP would be the concentration of barium ions and then the molar concentration of sulfate ions. So this is our KSP expression, and say we have some sulfate ions already present in solution, this will increase. Therefore, we're going to have to shift to re-equilibrate that equilibrium. Because our KSP value for barium sulfate is a set value, is a constant value. So let's take a look in sample exercise 14 here. What happens to our calcium fluoride here as far as how much will dissolve when we have a common ion present. So we're given our KSP value up top here, 3.9 times 10 to the negative 11, and we're going to utilize that in addition to our dissociation equation here. So here we know we're going to get 1 calcium ion and 2 fluoride ions for every 1 mole of calcium fluoride. So we're going to use this to set up our KSP expression. So that will look like this here. We have our molar concentration of calcium ions, and then here we're going to have our molar concentration of fluoride ions, and we know we need to raise this to the second power because of that coefficient there. And we know that this is all equal to 3.9 to the negative 11. So let's see what happens here. We're going to create an equation where we have our solubility of calcium fluoride being the variable S, and then our calcium being the variable S, and then our fluoride will be 2S because of those coefficients. So let's set this equal here, 3.9 times 10 to the negative 11 equal to S times 2S. Don't forget to square it. And we get that our 3.9 to the negative 11th is going to be equal to 4s cubed, doing the product of these two values here. So we can divide both sides by 4, and then we can take the cubed root. So if you remember, another way of doing that is raising to the 1/3 power. So depending on your calculator, one may be easier than other. So when we divide it by 4, initially we would get that this was equal to 9.75 times 10 to the negative 12. And once you take the cube root of that, we're going to find that our S that we solve for, our solubility, is going to be 2.1 times 10 to the negative 4 molar. All right, so we solved for the solubility when our calcium fluoride is dissolved in water.